Yeah, my name is Sahid Bayole Adisa. I'm a grad student of the Department of Material Science and Engineering at the University of Idaho. So now I'll be talking about magnetic particle inspection, which happens to be which happens to be a very simple method. So now, what is magnetic field inspection? This magnetic field inspection we're talking about is based on the principle of flux leakage. And how does this happen? During MPI, which is magnetic particle inspection, there is a generation of magnetic field, and this magnetic field has a strong north and south pole. So if there is any defect in the material, this defect is going to inhibit the alignment of this field, and this inhibition of magnetic field alignment is called flux leakage. And the magnetic particle used in this experiment can either be fine or ultrafine, ion or magnetite. So now I'll show you how magnetic particle inspection experiment is being done. Experiment, I'll be using a magnetic field inducer, and the model of the machine here is called Magnafloss model Y7. So, and here we have the squeeze bottle, and this squeeze bottle contains our ultrafine ion particles. And here is my sample. This is the sample I'm about to investigate, which has been previously cleaned with acetone, so that we'll make sure it is free from dirt or debris. So now the first thing you need to do is to get your safety glove, because sometimes the current in the machine can be too much that it can get you electrocuted. So you just have to ensure your safety first. And yeah, this is the machine. The first thing you do is you make sure that the leg of the magnetic flux inducer is closer to the area you're about to inspect. And how do you do that? Yeah, this is the joint we are about to investigate. So we only want to investigate if this joint has some cracks or some cavity anyway. So yeah, here you can see how I'm trying to manipulate the legs so that it will be closer to the inspected area. And the first thing, and another thing you need to know is that you need to make sure that the legs of the magnetic flux inducer flush perfectly with the sample that we are investigating. Because if you don't do that, those holes will serve as flux leakage. You'll be seeing it as flux leakage instead of the actual crack in the material. So, secondly, I'm going to plug the machine, and in this machine you can decide to go AC or DC depending on what you want. If you want a continuous magnetic field, you put it into the DC mode. Here you put it into DC mode. So if you want to vary your magnetic field, so then you put it in the AC mode. But here I'm going to use it at the AC mode. And yeah, make sure that you hold the machine firmly to the material and try to press the start button here. So you use this squeeze bottle to blow the magnetic particle away so that you can actually see which area has cracks or cavity. Yeah, from this investigation that we can see there's a cluster of these magnetic particles around this region, which means in this region we have some cracks or some cavity. That is obvious. So this is as simple as this experiment is, and as I've said, is a very simple method compared to other methods of non-destructive testing. So I wish you good luck. God bless you.